What is garbage collection?
Garbage collection is a feature in many programming languages that automatically manages memory. When a program creates objects or variables, they use up memory space. Once those items are no longer needed, garbage collection detects and frees that memory. This helps prevent memory leaks, which can slow down or crash programs if unused memory builds up over time.
Why automatic memory management matters?
Manually managing memory can be challenging and error-prone. Forgetting to free memory can cause leaks, while freeing memory too soon can crash a program. Garbage collection automates this task, making programs safer and easier to write. Developers can focus more on solving problems and less on tracking memory allocation, which helps reduce bugs and improves reliability.
How garbage collection works.
Most garbage collectors use algorithms to track which pieces of memory are still in use. Common methods include reference counting, where objects are freed when nothing points to them, and tracing, which finds unused memory by following active references. Garbage collection usually runs periodically, or when memory is low, reclaiming unused space for new objects.
Impact on program performance.
While garbage collection simplifies programming, it can affect performance. The process may briefly pause the program to find and clean up unused memory, which is sometimes called a stop-the-world pause. Advanced garbage collectors use techniques to minimize these delays, but developers should be aware of potential slowdowns, especially in high-performance or real-time systems.
Languages that use garbage collection.
Languages such as Java, C#, Python, and JavaScript all use automatic garbage collection. Each language may implement it differently, but the goal is the same: to manage memory safely and efficiently. Some languages, like C and C++, do not include garbage collection by default, requiring programmers to manually handle memory allocation and freeing.